Hello guys, welcome to the third video in this series. Now in this video we're going to be talking about the fundamental data types in Rust, also known as the Rust primitives. So these are the basic data types that are available for you to use inside of your Rust program, and it's just the same as what it is in other programming languages. So we're gonna get started with that in this video. So the first ones we're gonna get into are the integers. So we have a bunch of integer types available in Rust, and unlike C or C++, these are actually available in the core language. So for example, we have the so let me just explain to you guys how to declare variables first of all in Rust. So if you want to declare variables, you type let something equals to something else, and then you put a semicolon at the end. So this is actually what is called a statement. Okay, so a statement in Rust is denoted by typing a valid syntax and then ending it with a semicolon. So of course something else is not actually a valid statement. I mean, what the hell is that? Anyway, so if I want to declare maybe like an age, I can say it's 21. I'm not 21, by the way, I'm probably older than that. So so let's say age is 21. All right, so I want to print this out. I don't know why you want to write a program where you print something like this, but if that's what you want to do, if this is your dream, then you're probably writing your dream program right here. All right, but so if you want to print this out, you could definitely do that, and then make sure you save the program and hit cargo run, and you should see age is 21 printed down here, right there. So this is but you might be wondering, as you can see, I didn't denote or I didn't specify exactly what type this variable actually is. So what exactly does this variable, what kind of type is it? An integer? I mean, this is an integer, we know that, but I can also put 21.4. now I've never seen anyone that's of age 21.4, but we could definitely do that. And we say that Rust is a strongly typed language. So if Rust is a strongly typed language, then this variable definitely has to have some concrete type, right? Well, definitely it does. Actually, the reason Rust actually didn't require us to use a type here is because it was able to deduce what type this variable actually is. So this 21.4 is definitely a float. I mean, you might wonder though, is this a 32-bit float or a 64-bit float? Well, this is a 32-bit float because 21.4 can actually fit into 32 bits. So 21 is, this is definitely an integer, but is it a 32-bit integer or a 64-bit integer? Well, this can definitely fit into a 32-bit integer, so why should we be surprised if this is actually a 32-bit integer? So if we hover over this, you can see that age is equal to I32. Apparently the Rust developers didn't like typing, so instead of like having a variable where we have integer, they just decided to call it I32 and be done with it. I mean, I love it. As you can see, even to type a function, they're too lazy to type a function, so just decided to make it from main. I probably would have preferred if you just named this like M instead of, you know, so we know that they don't even type at all. But anyway, it's cool. I'm just kidding. So if we wanted to know the type for this to be more explicit, we have I32 right there. Now, if I save this, this should definitely, what is going on here? I don't know what's going on. Anyway, I'm gonna run this program again to see if the errors can go away. Okay, so we have age is 21 here. I don't know what this underline is supposed to mean. Get out of my face. Anyway, so this is how you declare variables in Rust. Okay, so if I wanted to use 21.4 for example, this is probably not gonna work. And if I run it, let's see, definitely it didn't compile. What did it say here? Mismatch types, expected I32, found floating point number. I mean, this is crazy. Why would we want somebody's age to be 21.4? Anyway, so this is exactly what I'm saying when I say that Rust is a strongly typed language, so it requires us to have some variable that actually makes sense corresponding to the type. So I'm gonna list a bunch of the fundamental data types available in Rust. So we have the I32, we have the I64, we have the U32, U64, we have the F32, we have the F64, we have the U size, and we have the I size. And I'm going to explain what all these are in a minute. So first of all, we're going to let age I32 equals to, let's just say 20. Now, as you can see, like I said earlier, you have to put a semicolon at the end of your statements when you're writing code in Rust, right? So if I run this, the program is going to run just fine, right? I can also put an I64 here, which is simply a 64-bit integer, okay? Now, run it again, and we should be good, as you can see. Now, what about the U32? Well, we know that there's some integers, especially from C++, that we have the 32 bits. We have the 32 and 64-bit integers, but they can also be signed and unsigned. Okay, so I64 is actually a signed integer, which means it can contain negative values. So, for example, if somebody is supposed to be minus 20 of age, I don't know. I feel like the person is like owing God like 20 years or something. I don't know how that is possible, but anyway. So, you know, if it's possible for somebody to be minus 20 of age, then this guy is minus 20. Okay, he's probably 20 years late. Anyway, so if you're declaring an age variable in a program, it's actually nonsensical to allow age to be something like I32 or I64, because we know that someone's age cannot actually be negative. So in this case, you should use an unsigned integer. So in this case, you could use U32, and if you run the program, it should definitely not compile, because unsigned values are not supposed to contain negative values. So as you can see, it says cannot apply unary operator this to that. I don't know how. It says unsigned values cannot be negated. So this program is going to compile if you just use 20, and the program is going to work just fine. And what does this allow you to do? This allows you to completely this allows your program to be completely how would I put it, a little bit more robust if you use the correct types in the correct places. But we're gonna get into that in subsequent videos. I almost forgot one very important fundamental data type, and that is the bool. You know, Boolean, where you say true or false and stuff like that. Anyway, so we've covered the I32, I64, U32, U64, 32 and 64-bit signed and unsigned integers. We also have the F32 and F64. So those are the floating point by variable types. So you can say, let me see, amount. So F32, which is going to be like, you know, okay, I'm gonna do pi, because why the hell not? So 3.1415, and I can print pi right here. And if you've never printed pi in your life, this is your chance. Make sure you write the code and you run it, and you get pi. Okay, definitely not. This is not supposed to be h, this is supposed to be pi. And so we're gonna run the program again. Make sure you write correct programs, and you can see pi is 3.1415. Congratulations, there we just wrote our first pi. Anyway, so the same you have here, 32-bit precision. If you want more precision, you could get yourself 64 bits, and you run it, and this is what you get. Now you might be wondering, if we take off this, what is Rust going to what type is Rust going to assign to this? Well, it's going to assign the F32. Why is it going to assign F32? Because 3.1415 can fit into an F32. So if you hover over this, you should get F32. Shit. Why the hell is he using F60? I have absolutely no idea. I mean, this is crazy. He just called me a liar. Anyways, guys, I think Rust decided to use F64, but it didn't matter if you use F32. I think the compiler is just crazy, okay? Anyway, it doesn't matter. Just we're gonna keep it. So as you can see, I think by default, let me see if I use 3.1 and it still uses F64. Okay, it uses F64 by default. I'm sorry, but yeah, that's what it is. So if you run a program, though, the behavior shouldn't change. So now we can see that if I use 3, what do I get? This is I32 by default and F64 by default. So make sure you note that when you're creating variables like this without explicitly stating the type. Okay, so that is that. Now what about the U size and I size do we have here? Well, that's actually simple. That's kind of easy to explain. The U size and I size simply is like a platform dependent size. So for example, if you're running on 32 bits, U size is going to be 32 bits. If your system architecture is 32 bits, usize is going to be 32 bits, and if it's 64 bit, usize is going to be 64 bits. Same with isize, except usize is unsigned and isize can contain both signed and unsigned values. Okay, so you can see here, isize actually is signed, so which means it can contain both positive and negative. Usize is an unsigned, so it can only contain positive values. And here we have the Boolean. So what does a Boolean look like? A Boolean is simply, well, let is crazy. Okay, I'm just gonna show you this. So it's true, and so we're gonna do is my brother crazy, and we're gonna do is crazy. Now, as you can see, there's like a squiggly under here, and as you can see, it says variable is crazy should have a snake case name. That's because the Rust developers are kind of crazy about the way you name things using their language, and they always complain about everything, even if it doesn't make any sense. So according to Rust, you should basically use snake case. And you may be wondering what snake case is. Snake case is basically just any case that looks like a snake, something like this. Okay, so this actually works. So if you save this, you shouldn't have the snake issue anymore, and hopefully your program should compile and run without any warnings. Oh, by the way, it's not like your program is not gonna work, but if you try to run this program and you basically compile, you see a bunch of errors here. You didn't do anything wrong. It's just because Rust loves snakes. So please make sure. I mean, maybe Rust and Python, they kind of have something similar going on. I don't know. I'm not sure. Anyway, so you can see let is crazy equals true. It says convert the identifier to snake case. I think they should really change. I don't know why didn't they use like lion case or goat case or whatever. This is discrimination. Why the hell can Rust love snake? Anyway, it doesn't matter. So basically, you have to change everything to snake, and your program is gonna work without any issues. So is my brother crazy? True. So if you change this to false, then is my brother crazy? False. So that's basically it. And there is more to talk about. In the next video, we're gonna talk about tuples. And we're gonna go into also if selection and basically selection and if statements and match statements in the next video. I hope you enjoyed this. I'll see you guys in the next one. Bye. I don't know what to press to